Hi, I'm Marlise Dumais, and I'm part of Group 23, and I will be presenting the intro and unsupervised learning portions of our presentation. For our project, we decided that we wanted to perform genre and age prediction of songs using their audio data. Using a dataset comprising of features such as tempo and harmonics, we will train our model to provide accurate results. We hope the results can serve as a tool for educational and personal listening purposes. Our dataset was taken from the Kaggle website. There were two different datasets. One dataset consisted of 1,000 points of 30-second WAV files that spanned 10 genres. There was another dataset consisting of 10,000 points, which consisted of the same 30-second WAV files split into 3-second WAV files, thus producing 10 times the amount of data for each genre. There were 60 features for each point, and they spanned tempo, harmonics, chroma frequency, spectral roll-off, and more. This now leads us to the unsupervised learning methods that were used to perform the classifications for this project. The two unsupervised learning methods that were used were K-means and Gaussian mixture models. In brief, we developed an accuracy model to follow to help achieve our results. Seen in the image below, we found each genre would have a distinct common cluster number. We would then find the percentage of accuracy for that genre within that cluster. Afterwards, doing that for each genre, we averaged out these percentages. We then used this overall accuracy percentage to measure the results of our clustering methods. This method could be done because each genre clustered to a distinct majority cluster number. So for our unsupervised method results, these were the following. For starters, we scaled our features between -1 and 1. We then used BCA to remove insignificant features. That resulted in now working with 42 features rather than 60. Overall, GMM achieved better results as the accuracy was higher than K-means. This is probably due to the features being weighted in GMM. Also, the 3-second dataset, which consisted of the 10,000 data points, provided better results, i.e. higher accuracy. This could be due to the sampling window being smaller, thus giving more varied data. Furthermore, to help accuracy results, we decided to partition our dataset into 4 supergenres. This then resulted in a much higher accuracy result, 62%, relative to clustering with all genres separately, which resulted in a 42% accuracy as stated on this slide. This slide shows the visualizations of our clustering method with the results for the clustering of the 10 genres on top and the results of the clustering of the 4 supergenres on the bottom. The plots consist of the first 3 principal components. This now leads to the supervised learning portion of this project.
While unsupervised methods were honed for the purpose of grouping songs within similar genres and cannot be used to specify genre names, supervised methods were then used to predict specific ages of each song. We first used supervised methods to predict the ages of songs within one genre. Then we expanded these methods to the entire dataset. We then used the supergenre cluster numbers predicted in the unsupervised methods as a feature to use within the supervised methods. Then we predicted both the genre and the age using supervised methods. First, we use decision trees to predict the exact age value of each song within 10 years. We use both a decision tree regression and a decision tree classification with discretized data. We found that the optimal depth of the decision tree was 7 branches. We did, however, have a high variability of output in both methods due to a lack of randomization. In the end, the classifier obtained 70% accuracy, while the regression obtained 84% accuracy, both being within one genre. Some key features were the Mel frequency spectrum parameters, which are a representation of frequencies that are commonly used in voice recognition, as well as the perceptron variance, which is an important parameter for predicting song mood. Here are depictions of the decision trees from each method. Next, to add randomization, we used a random forest. We started with and adjusted the hyperparameters of the decision trees from the previous step and added randomization. Then we applied this method to the entire dataset. This, however, significantly decreased the success of our prediction. With the first method, we used a random forest full of regression trees and obtained 28% accuracy. In the second method, we used a random forest with classification trees and obtained 45% accuracy. We found that the classifier now had greater accuracy than the regression. This is most likely because the regression has a difficult time breaking data into distinct groups. This is an important process because songs within each genre tend to have similar age groupings. Here are depictions of each method, showing the first 5 estimators in the random forest. We decided that we needed to take advantage of the disparity in age feature dependencies between each genre. In order to do this, we used 2 methods. For the first one, we used the supergenre cluster number as a feature in the random forest. In the second method, we broke the songs into their supergenres and created a random forest for each cluster. With the first method, using a classifier decision trees, we obtained 50% accuracy. Using a regressor, we obtained 30%. In the second method, using a classifier, we obtained 38%. With the regressor, we obtained 40%. Method 1 most likely provides better results, since any inaccuracies in the GMM cluster number are mitigated by feature weights within the decision trees. In the second method, the regressor was now the more accurate type of tree, since feature age dependency is more uniform within genre supergroup. Finally, we used a random forest to predict both genre and age. Up until this point, using unsupervised methods to find supergenres still led to low accuracy when predicting song ages for multiple genres at once. Therefore, we used a random forest to predict the genre as well as the age. This also allowed for actual genre classification rather than simply clustering songs. In order to do this, however, you would have to have genre information available for each song in the training data, which is not always practical for every application. First, we used a random forest classifier to predict the genre, since it is a discrete variable. We trained this method on 800 songs and predicted the exact genre of 200 songs, giving us an accuracy of 65%, which is significantly higher than the accuracy obtained using Gaussian mixture modeling. Then we added the predicted genre, whether correct or not, to the 200 songs. Then we trained on 100 of these to predict the age of the remaining 100. With this method, we obtained 92% accuracy, now within 5 years of the correct age. Not only do we have better accuracy, but we also have better precision. Here's a chart to summarize the results of the combined methods discussed in the previous slides. You'll notice that the accuracy decreases when supervised methods are generalized to multiple genres. Using a random forest for both genre and age classification proved far superior and practical compared to using unsupervised methods. In situations where genre is unknown, however, using unsupervised methods to first group songs into supergenres does indeed increase the accuracy of age prediction. One final conclusion is that a larger dataset would have been helpful. For example, within a 100-song dataset, a training size of 90 songs only leaves 10 songs to classify, which will result in a high variability of prediction success. Also, a random forest can only be so random with such a small dataset. Thank you for watching.